Uh, good morning, everyone. So we are presenting our presentations, the group 11.3. Um, Myself, Saifur Rahman, and we have our we have there are five group members in our group. There are Mukti Misre, Evans, myself, Saifur Rahman, Zamima, Ezekiel, Anshana Karanta. The research topic. So our research topic is AI-based decision support adoption in UK transport management, assessing success in traffic predictions and road optimizations. And now I will request my next team member, Jamima, to continue. Thank you.
As we presented in the last presentation, the research aim for this project is to assess the effectiveness of AI technologies in improving traffic prediction accuracy and optimizing route planning across major UK cities. Moving ahead, for research questions, as feedback given by Ms. Lian, we have reduced to only one research question from 5, and that is, in what ways do real-time data sources enhance AI model performance in managing and optimizing public transport routes across the United Kingdom? Followed by 3 research objectives, which are 1, to evaluate the role of real-time data sources, for example, GPS, IoT sensors, and traffic cameras in enhancing AI model performance. Second, to review existing AI technologies and algorithms currently used. And then lastly, to provide evidence-based recommendation for improving AI implementation strategies. Moving to the literature review, my friend Mukti shall take it forward.
Okay. Yeah, so good morning, everyone. So basis our research topic and research question, there were things which were done for the literature review. They covered majorly first 3 domains, which was what's the real-time data availability in the UK, how are AI models and predictions for optimization available, and how the real-time data are integrated into management system. Reviewing all across these 3 domains and identifying the limitations and the emerging gaps of our project, I continue to explain the first one, where so talking about first is real-time data sources in UK public transport. So first is Bus Open Data Services and TfL real-time APIs. The UK's Bus Open Data Service mandates operator to provide real-time vehicle locations, timetables, and updates, which the information we got from is the Department for Transport 2020. This infrastructure was positioned as foundation for advanced AI. Applied in public transport. All the in-text citations are mentioned in the slides itself. Coming to traffic and roadside sensor data, there were research highlights which stated the importance of traffic and roadside sensors, such as ANPR cameras and inductive loops, for capturing the live congestion and the flow data on the road. Coming to next, which is the passenger and the demand data. From the smart car logs to their mobile ticketing platforms and contactless payment system, which offered real-time insight into ridership patterns and crowding. So such data, which is demand-driven, it enables AI models to optimize headaways and adjust the scheduling based on live passenger needs. So we discussed about how the real-time data sources are already available in UK transport system. Now, second, the data was available for us is AI model for prediction and route optimization. So there have been models which showed us the bus arrival and the travel time prediction. That's the most mature application of real-time data in public transport. Also, there have been studies which showed that model which use real-time inputs outperform those based solely on scheduled data. So this is where the gap is there, that there are current models which work on the scheduled data and not the real-time data. So first gap was identified from this thing. Coming to second one, AI for route and timetable optimization. So the real-time data enables dynamic route and the timetable optimization. There have been argument that real-time time variability can be modeled to suggest more adaptive route strategies. So UK has been they have been trialing around the bus open data services, and they've explored data-driven timetable optimization, allowing other operators to adjust their schedules. Moving ahead, how the prediction optimization system is integrated. So there have been projects like Digital Twin, which illustrates the integration of predictive AI with real-time optimization. For example, there was like a Tees Valley Combined Authority Traffic Digital Twin, which uses real-time data. It also uses the sensor inputs and also the AI-driven simulation tools to support real-time decisions. So systems basically highlight the potential of combining multiple data streams for intelligent public transport. Now, the last thing which we got to refer is about how actually the real-time data is integrated in our transport management system based in UK. So the two things are, first is digital twin and smart corridors, which definitely allows operators to simulate scenarios using live data. They emphasize that integration enhances congestion detection, prioritization strategies for buses, and incident response. Second one, how the accessibility and equity implications are there. This research indicates that real-time data can reshape measures for transport access. Also, there have been articles which demonstrates that using real-time rather than scheduled data produces more accurate accessibility outcomes, which we already read in the second literature, particularly for passengers with disability. So now, post all this literature review, there have been 5 gaps which have been identified. The first is limited UK specific empirical evaluation, where despite the availability of rich real-time data sets, few studies assess how AI is supported by real-time data and how it is used operationally within UK control room or dispatch centers. Second is overemphasis on prediction accuracy. So most literature prioritizes statistical accuracy rather than operational impact such as punctuality improvement, reduces waiting time, or service reliability. Now, moving ahead, there was third gap which was identified as underexplored data quality and coverage issues. National Audit Office in 2023 and the Transport System in 2020 highlights issues such as inconsistent GPS feeds and rural coverage gaps, yet academic work has not fully examined how these affect AI model robustness. So moving to the other gap is that there was a limited research on multi-source data fusion. Although there were global studies which explore sensor fusion, there were few UK-based studies which investigated how combining AVL, traffic sensors, and passengers' data enhances optimization performance. And the last gap which we identified is organizational and human AI interaction gaps. Operational adoption barriers, including staff training, trust in AI recommendation and legacy systems are widely reported. And this data we got recently from DFT in 2025 and TRL 2023, but rarely analyzed empirically in public transport context. So, moving ahead with what philosophy has been used in this research project, and what is the research approach to this topic, my friend Evans will continue to take forward. Thank you.
Our research questions focus on 1. How AI performs in real-world environment. 2. Practical outcomes for transport management. 3. Combination of quantitative model evaluation and qualitative organizational insights. Then 4. Real-world usability adoption, and operational improvement. In this, I would say that it perfectly suits pragmatism, because in pragmatism, it mostly combines quantitative and qualitative evidence. Hence, we are going to use qualitative um, qualitative in qualitative strategies such as interviews with transport operators, documents, and case studies. Then quantitative strategies in performance metrics of AI models, real-time data analysis. Uh, we also focus our attention on real-world problem, because pragmatism always used to solve real-world problem. And our primary aim is to improve practice and understand what works better and why it works in real-time operational settings. Our topic is about improving rail transport management, not just building theoretical models. Then the last one, when we in which also clearly shows that it is pragmatism, is that it allows flexibility. That is, AI plus transport research deals with changing technologies, multiple data sources, practical constraints, and organizational behavior. And with this, pragmatism always allows to adapt methods that are needed to solve real life problems. Now, moving to our research approach shall be adaptive. Yeah, it fits the study best because we begin with existing theory, that is AI model performance, data-driven optimization, and real-world time analytics is still going on. The theory is already there. Then we collect real-world data, from UK public transport systems. You use BODS, TFS, APS, APIs, and case studies. Then observe patterns about how real-time data enhance or fails to enhance AI performance. Yeah. Then from these observations, refine or update the existing theories. Abduction approach mostly bridges deductive testing and inductive exploration, making it ideal for emerging fields like AI adoption in transport. For the closure of this presentation, my teammate shall take the final part, research strategy. The final part, which is research strategy and research choice. Thank you.
Research strategy for our topic shall be mixed method inclusive of quantitative AI model performance analysis, then qualitative interviews and documents, case studies, TFL, Tees Valley Digital Twin. And our research choice shall be which integrates numerical analysis plus human insights, supports triangulation, and produces holistic understanding. Then here are the references which are also used as a text citation which we referred for this project. Thank you.